Now that is Indian. Start again. Yeah. So the heading is creating different type of arrays. Creation of See what happened, guys. Most of the people ask me this question that why are we learning this topic of creating arrays? Okay, basically, what happened to understand something, you have to also understand the creation of it, how it is going to get created, how it is working, what are the indexes, how rows are getting created, how columns are getting created. So, to understand the arrays bit more better, we go with this creation factor. Okay, now consider we are creating one Numpy array and I want to change the data type of that array. For example, the array is ARNUM. Okay, how we create Numpy array? Simply write np dot array. Inside that, 1, 2, 3, 4. Consider we are creating one Numpy array and I want to change the data type of that array. For example, the array is ARNUM. Okay, how we create Numpy array? Simply write np dot array. Inside that, 1, 2, 3, 4. Okay, what is this? If I check the D type of this array, it is going to come out as integer, right? But I want this array to be the data type of float. So I can mention the data type here as float. So basically what we are doing, this is the already created array. And if I want to modify the data type of this already created array, I can simply write the D type as float. Since I'm going to run this, or let's say I'm going to print this. Okay. Like this. You can see what it is showing me, 1 point, 2 point, 3 point, 4 point, and 5 point. Okay. Now it converted your integer array into the float one. So it's very simple. We do have one parameter present inside dot array method that helps us to mention the data type of the array. And according to that data type, it is going to create the array for us. Okay. If you want, you can pick this array and you can convert into integer as well. Okay. Let me show you some different ones. Suppose if I write AR of COM and then I'm writing np dot ARRAY. Okay. Inside that, I'm going to mention 1, 2, 3, 4, and I'm mentioning the D type as complex. We understand that complex is one data type which we have learned, right? So let me print this array of complex. You can see that now it is giving me one dimensional array containing complex numbers. 1 plus 0j, 2 plus 0j, but you can see by default this 1 is in the float format. Okay, so what are we getting, guys? It's very simple that whenever you create this array into the complex numbers, it is always going to put one decimal here. And after the decimal, it is going to be 0.0. Okay, no problem. Just for the preciseness. Okay, just to pick it as the precise value if in near future it is going to come. Although it is very rare that we are going to receive any complex type of value, but yes, if you want to change the data type, it can be done like this. Okay, we are focusing as of now on the 1D array. We will talk about 2D's array later. So let's focus on the 1D array because it has greater significance in upcoming sessions. Okay. Now, these two are, we were talking about the parameters available in the array method. Now, the another thing here is that creating array with the help of arrange method. Okay. Creating array with the help of arrange method. Now, you need to understand that arrange method, previously how we were creating the array with the help of np.array, right? Here we are going to create the arrays with the help of np.arrange. Now this arrange works as same as that of your range. Getting it? Chalo, could you please drop me the range function for printing the table of 2? Range function for printing table of 2. How you guys are going to define it? You just simply need to mention the range, no for loop, nothing. What you're going to write inside the range along with the range. Mm-hmm. Wrong. You have to print the table of 2. How you're going to print the table of 2 like this? The starting should be 2 itself, right? Table of 2. 2, 4, 6, 8, 10. This should get printed. Everybody is giving the wrong answer. Everyone. How we create table of 2, guys? Starting from 2. Let me give you the hint. Starting from 2. Yes. Ending at 21. Gurpal, again you missed something. The number of jumps, right? How range work, guys? Let me remind you. So range is somewhat like this. You have to mention starting from 2, ending at 21, and 2 number of jumps. Then it is going to print like 2, 4, 6, 8, 10. Getting it? So that's how your range works. Similarly, how the range is working, your arrange also works. Okay. You have to first mention the starting number which you want to start your range from. You have to mention the ending number where you want to end your range. Always remember that it is going to be but one value, which means if I want to print till 20, I'm going to pick 21. Okay. Now, the number of jumps. Okay. So this is going to be like this. A number of jumps could be any number. Okay. Right now, I'm just by default writing 2. Let me show you how we can create the array with the help of arrange. Okay. Simply, you need to write np.arrange. Okay. Inside that, I'm mentioning 1, 11. This is going to be a range. If you run directly like this, you will see it is giving you one-dimensional array. There is a catch which you need to remember. We cannot use arrange for creation of two-dimensional array. Let me repeat that again. We cannot use arrange for the creation of two-dimensional arrays. Okay, you can only create one-dimensional array with the help of arrange. Later, if you want, you can convert this into 2D as well. No problem. But by default, you cannot create 2D arrays with the help of arrange. Remember, this is one of your important interview questions, okay? They will always ask you to create two-dimensional array with the help of arrange. So you have to tell them that, of course, it is possible. First create this array and then reshape into the 2D. By default, you cannot create two-dimensional array with the help of arrange. Making sense? Getting the point? And similarly, if you want to create the array with table of 2, you can simply write 2 comma 21 to number of jumps. Okay. So you can do somewhat like this as well. So you can see the whatever the number you're giving in the starting position, it is inclusive in nature. Whatever you are giving the number in the ending position, it is exclusive in nature, not included. Okay. And 2 number of jumps we are talking about. Okay. So guys, do you understand that yesterday I told you one thing, that you have to print your arrays, then only it is going to look like this. Okay. So previously I'm not storing this into some variable or printing that variable, right? I'm just directly writing np.arrange and then printing it. That's the major difference it was creating. Getting the point? So it is just the declaration of your variable. We'll talk about reshaping this. Okay. This is one dimensional array. We are going to reshape it into 2. And this is very frequently used thing. Okay. Not everybody is going to sit and create 2-dimensional array, right? Because it takes a lot of effort. So what we do is randomly we create array with the help of arrange and then later convert it into 2D. Easier process. So let me write it down with reshape. Okay. So how reshaping thing works? Suppose I'm writing np.arrange for the creation of array. Okay. Let's say 31, comma 51. It's a 52. Now I am saying 3 jumps. No problem. Since we are having a dot reshape, I can reshape it to any 2-dimensional array. But now, do you guys understand one thing? Between 31 to 52, how many elements this arrange is going to print? Let me first remove this reshape and show you. 1, 2, 3, 4, 5, 6, 7. What is the size of this matrix? 7, right? So we have to create the 2-dimensional array according to that only. What all combinations are going to come for the 2-dimensional array that contains 7 elements within it? Since 7 is an odd number, we understand that we can only create 1 cross 7 and 7 cross 1 matrix. Right? Any other combination is possible? What do you guys think? 2 cross 2 contains 4 elements. 2 cross 3 contains 6 elements. Okay. Wait a minute. Gurpal, that is going to be single R. Okay. Not double R. So you can see ARANGE. So we can only create 1 cross 7 or 7 cross 1 matrix with the help of this arrange. Okay. Now, let's jump into this point. Now, reshaping we can do with this possible values only. So we have to keep the shape of the 1-dimensional array in mind before reshaping it. That is very logical as well, right? Suppose if I'm going to create this into 2 cross 2 matrix, what will happen? It is only going to pick up 4 elements. What about these 3? Where they are going to go? Nowhere, right? So we have to be pretty much sure that what is the shape or what is the size of the matrix first, and later in which shape or size I'm going to convert it. Okay, basic math. Now let me delete this. We are going to reshape it, simply writing reshape 1 comma 7. 1 row, 7 columns. Or you can simply write 7 rows, 1 columns as well. No problem. Running it. You can see previously that was 1-dimensional in nature. Now it turns out to be 2-dimensional. Okay. Let me give you some more example. Let's say np dot arrange. Okay. Let's do something like this. 1, 7. Okay. How many elements it is containing? 6. Now you want to reshape it. What all possible combinations? What do you guys think? For 6, if I want to convert it into 2D, what all possible combination of matrix are there? Give me the shapes for 6 number of elements. Possible combinations for 2D. 2 cross 3, converted into 3 cross 2, of course. What else? Predicted it correctly that it could be through 2 cross 3, 3 cross 2, 1 cross 6, 6 cross 1. Okay, 4 possible combinations. So I'm going to simply write dot reshape. My preference is 2 cross 3. Okay, my preference is 2 cross minus 1. So what I'm doing, guys, if you know the combination, but if you don't know, there is a possibility, right? For any number, the combination could be 2 cross 3, 2 cross 4 as well. Okay. So for such cases, if you're going to mention minus 1, it is going to by default predict the number of columns for you. That is not only for the columns, it's for rows as well. If you're going to mention the column, it is going to by default predict the rows for you. If you simply put minus 1 there. Okay. Let me give you the example. Suppose I'm writing np.arrange. Here I am mentioning minus 1, comma 6. Okay. Or you can mention 6, comma minus 1. So this is what it does. So if you know the number of rows or if you know the number of columns, okay, either of the thing you know, but you don't want to put manual effort or much of your brain knowing the other thing. So you put minus 1. Let Python decide it what shape it is going to be. Making sense? Getting the point? Look into this carefully.
If number of elements are odd in the array, then is it working or not?
Yeah, of course, no problem. If you are having the odd number of elements, then also you can put minus 1. Okay. Yeah, same can be done for the number of rows as well. Okay. You can use minus 1 either way. That is completely your choice. Okay, guys, so what is the question? There is always a question in the interview when they are going to grind you for the Numpy. What they are going to ask you, what is arrange? Okay, then you have to tell them that arrange helps us to create the array like this. Now, can we create two-dimensional array with the help of range? Yes, of course. You can say that yes, we can create. First, we can create 1D array with arrange, which is possible. We cannot directly create 2D array with arrange, and then later we can reshape it according to our requirement. Okay, this is very commonly asked interview question. Okay, let's delete it. Now we are going to create array of zeros. Okay, suppose if you want to create array all containing zeros, So you can simply write array of zeros like this. NP dot zeros. Inside that, if you're going to simply mention 10, because it takes first the shape of your matrix or array, right? If you're going to mention 10, you can see it is creating one-dimensional array. But later, if you're going to mention 10, comma 2, what will happen? 10 number of rows, 2 number of columns, like this. Okay. What is the D type of this array? If you want to check the D type, what it is going to show me? Float. So always understand that whenever you create array with the help of np.zeros, it is always going to create array in the float format, which later, because we do have D types here, you can simply put comma and you can simply mention D type. Mention this as the integer. You can convert it into integer as well. So by default, it is going to get created as float, which you can later convert it into integer. Okay. Giving you a minute. With odd number of elements, we can only reshape it to 1D, right? Because it is not uniform. Let me reread that question. With odd number of elements, we can only reshape it to 1D. 1D, which means you're talking about what? This reshape thing? This is already one-dimensional, right? We are having an odd number of elements which we created somewhere here. And if you are having odd number of elements, you can reshape it into 2D as well, no problem. But it could be only, the possibility could be 1 cross that particular element and that particular element cross 1 for the odd number of possibilities, right? For even number, we can have a different divisibility. Okay. Yeah, of course, we do have exceptions like 9, right? So can we say that let's summarize this to something called as prime numbers? Can we say that for prime numbers, we can only create a 1D array? We can convert 1D array into 2D array with the possibilities like 1 cross that number and number cross that 1. And if the number is odd and not prime, yes, of course, we do have possibilities. For example, 9, right? 9 is not a prime number. So we have possibility like this, 3 cross 3, 9 cross 1. Okay. So for the prime number, you have this number of combinations. If the number is not a prime and odd, you have such type of combinations. Okay. Now, do you guys know what is identity matrix? Anyone? Array of 0 we have created. Okay. Before going into identity, let's talk about the array of ones first. How we can create array of ones. Simply np dot ones. And if you directly mention the number like this, you can see creating one dimensional. It completely depends upon the shape which you are giving, guys. Okay. Now, if you're going to mention 10 cross 10, you can see giving a 10 cross 10 matrix. If you mention the data type as integer, you can mention like this and change the data type to your desired format. Okay. Okay. Are we here? Okay, let's talk about array of random elements. Since I'm saying array of random elements means what? We are going to create randomly declared elements. Now, since we are talking about random things, you need to understand that if data is random, if data is containing random numbers, okay? Okay, so this random numbers should be normally distributed. Normally distributed, there is a term related in the statistics for this random numbers called as standard normal distribution. You guys must be knowing this. What is standard normal distribution? If you don't know, let me give you the brief about it. Okay. Standard normal distribution says that, yes, of course, we are talking about the bell curve. Okay. So standard normal distribution says that if your array or data set is containing random numbers, so we don't know when, how many times 10 is coming, how many times 5 is coming, how many times 6 is coming, right? So random declaration of element makes sure that each number of terms is coming the exact time where it follows the random distribution to be normally distributed, which means it is not biased in nature. Suppose if I'm going to create the random data for the sales of some company X, we usually create such type of data and call this as dummy data. Since this data is not biased in nature, we are going to do the comparison how biased data is working with my algorithm and how unbiased data is going to work with my algorithms. Okay. So suppose I'm going to create array of random elements. Now, if I ask you to create 20 cross 20 matrix, so how your brain functions, you're going to simply write np.array. Inside that, we are going to write 10, 20, somewhat like this. So in your mind, random numbers, when you are writing, there is a possibility that it is going to, your mind is going to pick some certain type of number, n number of things. And that is going to make your data biased in nature. And I'm saying my data should be normally distributed or standard normally distributed, which means within the desired range. Let's say if I mention the range like 1 to 100, it should pick the set of elements exactly. Let me give you an example. This is 1 to 10 range, right? How many number comes here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm going to say that this data is standard normally distributed. You will ask me how? This is not random. You are just picking some numbers between the range. Basically, what happened? What is your highest number? 10. Okay. 9 plus 1. 10. 3 plus 2 plus 5. 10. Okay. And these combinations all together make your highest number. That is why we call that this data is standard normally distributed, because within the desired range, combination of numbers are also not exceeding its value. It is keeping, if I'm going to do the sum of two numbers, it is not going to exceed my higher value. Okay, 9 plus 1 also makes 10. 7 plus 3 makes 10. 6 plus 4 makes 10. 8 plus 2 makes 10. Job is done. Okay, so that's how we say that this number is standard normally distributed, because it is not going to create. No, I'm talking about, let me show you the combination. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is 10. Okay, 9 plus 1, 10, 8 plus 2, 7 plus 3, 6 plus 4, 10. If you pick the combination of 5 with any number, let's say 5 or 3 plus 2, 10. Right? What will happen in such situation? Every number already participated. Okay, so that's why we are saying that in this particular maximum number, every number is taking participation and we are not exceeding the value of 10. This already been used. Okay, but we are just using to match my exact maximum. If one or two numbers are excluded, no problem. Okay, so this random set of numbers are saying that they are standard normally distributed. There is one more tactic. You're not going to sit and check, right? If some of these two numbers are making 10, if some of these two numbers are making the maximum number. So there is the logic behind standard normal distribution, that your mode of the data, let's say median of the data, should always be equals to the mean of your data. If you're going to find the mean of this data, it is going to be same as the median of the data. What is the mean? Mean is the average, right? Sum of all the terms divided by total number of terms. What is median? The centermost element of the data set after arranging them in the ascending order. So this is the job for you today. Okay, go home, pick the numbers from 1 to 10. Okay, find the mean and median of that data. It will always come equals to each other. Getting the point? Equivalent to each other, equal to each other. Now, since you are taking very small set of numbers, suppose you are picking, and this standard normal distribution works with large set of data. Let's say 100 observations, 200 observations, 600 observations. We always consider those type of observations as, if you want to check that particular numeric column is standard normally distributed or contain some extremely high value or low value, we check if that particular column's median is matching with the mean or not. If it is greater than or less than, then we will say that data is not standard normally distributed. It is somewhere biased or contains extremely large or extremely small type of value. Okay, making sense? So since you can see this is 4, 4, 8, 9, 10, right? Let's pick odd number. Then I will show you. Any median for even number has different formula, kind of difficult as well. Tricky maybe. Let's find the median for the odd set of numbers. Okay. So if you're going to find the mean, you will, what is the mean of this term? You have to first do the sum of all these numbers. 9 plus 1, 10. 8 plus 2, 20. 6 plus 4, 30. 7 plus 40. And this is 45. 45 divided by 9. How much it is? Right? This is your mean. Now I'm going to find the median. Okay. How we decide the median? First, we have to arrange the data in the ascending order. It is arranged. Now we have to pick the centermost number. If we are having 9, and if we want to decide which one is the centermost, can we divide it directly with 2? Of course we can. Okay. 2, 4.5 something. We can take this approximately to term, it says. Okay. 1, 2, 3, 4, 5. What is the fifth term? So is mean is equals to median? Of course. The data is standard normally distributed. Okay. Now we have to focus, come back to the point where we were discussing the random elements. The major goal of the declaration of random elements is that it is going to declare the random elements within the desired range, but the element is standard normally distributed. Elements are going to be standard normally distributed. If you guys are going to create a bell curve for that, you will see the proper bell-shaped curve. We are going to cover this topic in pandas as well, but you just need to remember this randomness is not any sort of randomness. This randomness contains some logic, but it is not biased in nature. Every element and every term is taking participation in such a way that overall, if I'm going to do the sum of it, it will make the maximum number. Okay, how we declare this array of random elements? Let me simply write that np.random .random. Now, what you have to do, you have to mention. Okay, let's say if I'm going to write 10, you can see it is giving me the 10 element one dimensional array. If you want to create 2D array, you can simply write 10 cross 10. Something like this. Okay, so it's not looking that good. Can we simply write cross 5 so that it will appear? Okay, now you will see that if I'm writing np.random.random 10, 5, it is picking the shape of 10, 5, 10 rows, 5 elements, but it is giving me all the numbers in the float format. Right? What if I want to change this into integer? Yes, of course. So you guys must be thinking, can we simply write d type is equals to int? Now you will see something. Okay, what it is doing? We don't have any sort of argument called as d type here. If you want to create array of integer, we have some different methods. This is array of float by default. It is picking equal random numbers, but in the float format. Also, check your first number. What is this? 0.76317. Okay. Remember this number. I'm running the cell again. Is it the same number? Now it is 0.704. Again running the cell. Is it the same number? 0.695. What is happening? Each time I'm running the cell, my numbers are getting. That's what the job of randomness is. To give you a random set of elements every time. Okay. Since this is not the suitable format of data. Suppose if I want to use this somewhere else, it is going to keep on changing its number. How I'm going to do the calculation on the basis of this randomness? So we have something called as np.seed, okay, which helps us to fix the randomness of this value. So np.random.seed in any number. This number which we are mentioning inside the seed does not contain any particular logic. Okay, it's just the function is created in that way. We have to mention some value inside it, some argument inside it. Okay. So suppose if I'm writing np.random.seed, you can see again the randomness is happening. Now I'm going to run it. See what is the first value? 0.55. Running it. 0.55. Run it n number of times. Not going to change it. Okay. Getting the point? Now also understand this thing, guys. Whenever you are declaring the random element, always try to store this in some variable so that seed can work on that variable. And each time you are going to use X, it is going to give you the same random element, not the different one. Okay. Ask me questions if you have any. We can specify any value in seed. Yes, of course. Okay, there is no, as I told you, first thing in the Python which we have that contains no logic is this seed. It is just to fix the randomness of your data. You just need to provide any number. Okay, and it is going to fix your value. What if you specify any float value in it? Suppose if you are going to write 3.1, what it is doing? Type it. Okay, it asks you to give only integer type of. Now, let's talk about how you're going to create the array of random elements with integer type of value. Okay. You have to simply write np.random dot randint. Okay. Declare the elements like this. 10, 5. Okay. I will show you how we can create it. First, let me answer this question that why we will need random array creation in EDA. The answer is that for the dummy data. Okay. So whenever you need dummy data for your, let's say, processing or explorative data analysis, there are sometimes when your data is biased in nature and don't give you the correct set of calculations. So what we do, we create a random element array or array of our own choice, similarly matching to the characteristic of the data so that we can apply the algorithms on it and to check it, how it is going to behave on unbiased data, whereas how it is going to behave on the biased data. Which choice is suitable, and then we are going to move forward with that choice. Okay. If it is going to work good with that biased data, no problem. My data set is already biased. But what if it is going to work good with unbiased data? Then we are going to convert our unbiased data into the biased one and then apply it. Okay. Getting the point? What? Lakshmi, your output is going to be different. It should be different. What is the reason? We are declaring random element, right? What is the meaning of randomness? That could be different for you, different for me as well. Okay. Now come back here. Let me explain you this syntax. What is this syntax saying? np.random.randint for integer declaration. 5 to 10, which means this is telling you the lower range. This is telling you the higher range. And this is the shape of your matrix. Okay. Let's remove low and high, unless I have to mention shape and size as well. That's why I don't mention. Okay. So this is low, lower range, or let's say the value where we are going to start picking the numbers and the value where we are going to pick and picking the numbers. Understand that it is exclusive, same as that of your range. Okay. This is not included. 10 is not included. Up till 9 it is going to pick. Suppose if I'm going to change this to 5, 100, it's going to pick the elements from 5 till 99. Okay. Now we are having 5 to 10 as the shape of your matrix. So whenever you want to declare the integer matrix, or let's say random integer array, you have to always mention the range from where you want to pick the number until where you want to end the number, so that the randomness which Python going to declare should not be biased in nature. Okay.